My name is Petteri Juvonen. Welcome to this course, Methods in Macroeconomics. The course is about tools and models that are used in the contemporary macroeconomic literature to analyze mostly cyclical fluctuations. First few practical issues. There will be all the lectures will be video lectures. There will be problem sets and then online meetings to discuss on the topics of lectures and get some guidance for problem sets. There will be a presentation on some research paper. There is a list of papers at the course webpage. I will update it soon. Then there is a final exam, which will be really similar to problem set exercises. And in the grading, problem sets have a weight of half, and then exam and presentation the other half. There is kind of a theoretical part and empirical part in this course. First, we study DSG models, real business cycle and New Keynesian models. And then we will move to empirical time series models and Bayesian estimation. This is an applied course. There is lots of different tools and models in this course, so idea is not to get really full theoretical treatment of everything, but get the idea and understanding what these models mean and how they are used in practice. After the course, you should have an idea first what these models are and have an understanding of their pros and cons, and then be able to read recent research literature where these models are used. And then after some additional work, to even use some of them in your own master thesis work. So we are going to focus on models and tools that are really used in cyclical fluctuations and for medium-run macroeconomics in general. They can be used to answer two questions. What causes business cycles? And then is there any role for stabilization policies? This is US GDP growth, or log GDP, where we have a trend and then the original data. So the difference of these series are the cyclical fluctuations. We could really ask why it has to be so that the economy is not growing at a constant rate. Wouldn't be much better for us all if there wasn't any cyclical fluctuations, but just stable growth rate. But there are a lot of cyclical fluctuations. They are a frequent phenomenon of market economies. They are not regular, but they are frequent, occurring every now and then, lasting from a year to a decade. What this means in terms of welfare is that cyclical fluctuations are periods of under and overuse of resources. This is cyclical components of output and hours. So there are periods of low use of labor input, meaning periods of high unemployment, and then periods of low unemployment, and even use of kind of overuse of labor, so that people are working longer hours. And this applies more generally to whole production, so that economies are not at their optimal potential GDP all the time. Instead, there are under an overuse of resources because of cyclical fluctuations. Given the welfare cost of cyclical fluctuations, it would be useful to know better what causes and what can be done for cyclical fluctuation in terms of economic policies. We could analyze things with ADAS curves to get an intuition. For example, current corona epidemic and its effects on economy could be analyzed by these curves so that there is a shift in both in aggregate demand and short-run supply, which move the economy away from a long-run aggregate supply curve. But with these with this kind of approach, one cannot really tell any quantitative answers on cyclical fluctuations, only get the intuition or some principles. That's why we need to have some other kind of tools for deeper analysis. So-called dynamic stochastic general equilibrium models have been the main tool for this for several decades already. They came into picture from real business cycle theory, which argued that cyclical fluctuations are driven by productivity shocks, and then the economy responds optimally to these, for example, so that when there is a negative productivity shock, it was actually welfare beneficial to work less due to low productivity period. Then came a new Keynesian theory, which argues that yes, fluctuations are caused by shocks, but there are imperfections so that agent responses aren't efficient. And because of these inefficiencies, there's room for fiscal and monetary policy to improve the adjustment of economy on shocks. Today, focus is not only on productivity shocks, but also on demand side and financial market originating disturbances. But although this early real business cycle theory has lost its explanatory power during recent decades, still it plays the ground for DST models that are used still these days. So what are these DST models? They are dynamic in a way that these models produce a time path of variables. They produce a time series for variables. And agents in these models are forward-looking, which means that expectations are important, how we form the expectations, or what we assume, how we assume the agents form their expectations. There is stochasticity, the shocks that create unforecastable movements, and they are general equilibrium models so that allocations satisfy optimality conditions of optimizing agents and aggregate resource constraint. So they are kind of a mixture of micro theory and time series econometrics, so that there is a optimizing agents at the micro level, which then produce behavior which can be cast in a time series model actually. So the core consists of optimizing problems of forward-looking households and firms. And this was really the response to Lucas' critique and lays ground for the micro foundations. For example, we could think that, okay, consumption is a function of income, after-tax income, and it depends on some constant C. Marginal propensity to consume out of after-tax income. we could estimate this for some data period and then change tau to see how tax change affects consumption. But the problem with this approach would be that we can't be sure whether this C is independent of tax rate, or is it that when tax rate changes, also C this C coefficient changes too. And this is the essence of Lucas critique. So we need to separate policy parameters and then deep parameters which are invariant to policy. So how this is done in DSC models is that there are maximization problem which specifies then the consumption behavior of household, and then it changes when we change some policy parameter. And then we have policy parameters and then other deep parameters which determine the behavior. There is, for example, discount factor, and in the utility function there are parameters which determine how a household changes its consumption plan. Of course, there is some questions when the models are estimated whether this really holds that there are policy parameters and deep parameters, so that deep parameters won't change if there are significant policy changes, but that is the aim of DSC literature anyway, to separate policy parameters and deep parameters. So DSC models consist of optimizing agents, household firms, at least they can be banks, different types of firms. Then there are frictions that regulate kind of the behavior of these optimizing agents. They cannot typically freely set prices and wages. Instead, their price and wage stickiness. They can be investment adjustment cost or habit persistence in consumption, so that past consumption matters for utility what agent gets from today's consumption. And then there are different kind of shocks that cause the dynamics. And then frictions and optimizing agents rules determine how economy responds to these shocks. This could be a really simple closed economy DSC model, so that there are households which supply labor and rent capital to firms. Firm produce output, and output from output firms obtain new capital. No, households obtain new capital and rent it to firms, and other part of output is used for consumption. Then there's central bank, which interest rate setting matters how investments and consumption plans are made. What are used in practice, the models that are used in practice are quite big these days, especially when they are used for in policy analysis in some institutions. There can be even 100 equations in these models these days. Although the seminal work from so-called medium-scale models, Smets-Borders, was quite compact and understandable model, but now there has been a lot of additional features to these models. This illustrates INO 2.0 model used in Bank of Finland. There are, in addition to households and firms, there are banks which collect deposits and give loans to entrepreneurs that supply or rent the capital. There are different kind of production, capital good producers, intermediate good producers, and then retails that combine exports and imports as a consumption and investment goods. So after introducing different kind of features, these models tend to get quite complicated. The dynamics of the models are determined by parameter values. And these models can be parameterized just by taking some conventional parameters that others are used if one is not so interested on precise quantitative results. Then these can be calibrated to match some features in the data, or then these models can even be estimated with Bayesian methods, which is typically computationally quite demanding task. Typical exercise is to use or run so-called impulse responses analysis, where we hit the model with some shock and then see how other variables respond. This can be a policy shock, for example, monetary policy shock, or then it can be some other shock, for example, demand shock. Then we can change policy rule, for example, monetary policy rule, and see how the model responds then under this different rule to shock. Or then we can include something else to the model and see how this changes the dynamics. These are impulse responses from Smets and Waters 2007 paper. There is on the first period an unanticipated monetary policy shock which increases interest rate. So it's a monetary contradiction. And the output responds negatively because there is a less aggregate demand. Ours respond negatively too. And then firms respond to this by lowering their prices. So one can analyze how large are effects from monetary policy to real economy through this kind of models. Then one use of these models is to analyze data. This is Danish real GDP, and it decomposes the movements in the real GDP to different kind of shocks, to markup shocks, demand shocks, productivity, foreign shocks, and fiscal policy shocks. And it shows that foreign shocks were the biggest reason for drop in 2009 in Danish GDP. DSC models give intuitive results and are usually quite easy to interpret, but their empirical fit is not so good since they are theoretical and quite restrictive models. The other type of models that are heavily used in the literature are structural VARs, which are time series models with some structural restrictions to identify structural shocks. The idea is to use as less theory as possible to credibly identify different shocks. And originally in the Sims seminal paper, the task was to identify monetary policy shocks. Why this is not so easy is that all macro variables move together, but it's really hard to separate causality and correlations. We can see that interest rate and prices move together, but is it only because of interest rate are responding, policy rate are responding to prices, or is there also some influence of policy rate to prices? So this is really hard to identify, and one needs some identification restrictions to be able to do it. Purely empirical methods are difficult to use for it. This is Ulik 2005, which shows impulse responses to monetary policy shock. The middle line is the mean impulse, and then there are confidence bands, and the timeline is in years. So there is again increase in federal funds rate. We see a quite mild impact in GDP, then a stronger impact in GDP deflator, and then reserves are responding negatively too. But this is a more empirical way to quantify the effects of policy shocks. Okay, this is shows the content of the course. We are first studying simple optimization problems of household and putting then these into a simple DSG model. Then we will move to a DSG RBC model with capital, and with this we are able to match some empirical features by calibrating the model. And to know about business cycles, we study a bit what kind of filters there are to isolate cyclical and trend components. Then we will introduce market imperfections in forms of sticky prices and wages, and go to new Keynesian models, which are used for monetary policy studying. And then we can combine RBC model with some extensions and a new Keynesian model to get a so-called medium scale DSG model and see how it works. There will be one lecture on unconventional monetary policy, and then we will move to empirical part and first study these structural VARs, how they are used and what it means to identify shocks. Then there will be estimation on Bayesian VARs and about the principles of Bayesian estimation. And then for the last, we study how Kalman filter is used for unobserved component models, models that contain some unobserved part, and DSG model is one such a model, and we will also look at how estimation of DSG models works. So this is the plan for this course. Then there is something, few suggestions to read related to topics in this course.